Okay, this video is going to be a continuation of the last video with React, Vertx, GraphQL. This time, last time we had an in-memory data store and we were updating that data store and retrieving from it. So this time we're going to access a Postgres database and get the data and save the data from there. So what I'll show you is that I've already created the database. It's going to have our two tables, tasks and users, with the same fields as before. And we're going to be using the Reactive Postgres SQL client for Vert.x. So the reason why I want to show you what calls using this thing look like is that they're pretty involved, especially if you, for example, if you look at this call, they set up the connection options referring to the correct database, the user account. Then a pool is created, a pool of connections to the database, and then you just grab one of the connections and you run your query. The thing is, you have to check that it's successful, then you have to grab it, then you have to run your query, then you have to check that it was successful, then you have to grab whatever results came from it. If you want to run another one, then you run another one, and then you always have to remember to close it. So having to do this over and over again on all of the calls within a application can be error prone and redundant and difficult to read. So we're going to use this client, but we're going to refactor code so that it's in a separation of concerns, single responsibility sort of style. And because, as you can see here, this is using the older callback style, it's not only is it harder to read and potentially deeply nested, it's also not idiomatic for Kotlin. So I want to do some updates to the code around that as well. So the first thing that we need to do to get started is we're going to update the entity data, this guy right here. So this class had the hard-coded in-memory data, and then it was just grabbing from those collections whenever something needed to be returned. So we're going to basically get rid of all of this. So in order to do this, the first thing we'll do is we'll create some new data classes a la Kotlin style. So I'm going to keep the existing entities. I'll just leave those for now, and then we'll create these guys. All right, so this is what we're going to be passing back and forth. This is what we're going to convert the data that comes back from the database as. So now that we have that, we're going to update the companion object so that it sets up the the pool properly. So the first thing that we need is this thing called a PG connection options, PG connect options. So what this thing does is it basically gives you or sets up all of the information about the specific Postgres server that you're on. So the IP address, the host name, the port, the username, password, stuff like that. So this thing is going to require accepting of the vertex object, and we're going to pass this down the code path, and I'll show you how we're going to do that in just a moment. So here, create my instance. Now, like I was saying before, I want to be idiomatic Kotlin style. So I'm going to use Kotlin features wherever I can. So that's why I'm using apply. And I do think it definitely cleans up the code a lot. So that's our database. Obviously, you don't want to have this kind of password in real life, but I'm just showing this for demo purposes. So this is the connection pool. It's sort of like a thread pool. It's going to have a finite number of connections to the database for resource saving purposes, and you can set how many you want by setting this. So we're going to start with 5. All right, so before we continue, we need to update this call from the schema wiring. Again, that's the thing that's going to merge our schema file that has the representations in GraphQL format of our data to the actual data getters or data resolvers. They're called fetchers in GraphQL-Java. So in order to bring this down the whole code path, I'm going to put vertx into here. Then I'm going to redo the signatures. So I'll just copy and paste these. Before I continue here, let's update this guy and wrap our class around it. So the reason why I did this is so that our companion object will be initialized, and this vertex object coming in will be applied to the pool so that the pool knows that we're part of vertex and it won't block the event loop. So that's why I did that. So then now that we are here, we need to start updating our calls, because again, we're not going to the in-memory store, we're going to the database. But before we do that, what we're going to do is we're going to create a data helper class that's basically going to, let me show you the website again, prevent us from having to, write this long complicated code over and over again. So I want to create some helpers that will eliminate that need. So I'll call them and again, because we want to be idiomatic Kotlin style, I'm going to use suspend. So this is the part that I was struggling with, because the coroutine stuff is pretty foreign to me, and I was trying to figure out a way to do this but also do it in that idiomatic style. So then I found this suspend coroutine. So basically what this will do is whenever an asynchronous call in that callback style is gonna complete, this guy is going to intercept that basically and notify whoever cares later downstream that that work has completed. And in this case, we're talking about the work of getting a connection asynchronously. So as before, let's see if I can get back in here. As before, we need to check that the attempt to get a connection was successful. So that's what we're trying to do here. And then if it wasn't, then we'll give we'll handle the exception. But right now, all we're trying to do is we're trying to get that connection, right? So we return the connection by passing it into the suspend coroutine via its continuation. But if it fails, then we resume with an exception and we give the cause. And then now we have a suspend function to get connections. And then you're going to see once I bring these together how much better it is to read this kind of code. But so the next thing we want to do is we want to be able to run a query, but do it with a parameter. So we're going to take the connection pool again. We're going to take a string that represents the query. In this style, it's using, I guess if you're from C#, it's using like ADO.NET style. So you have string queries. But the tuple, and I'll show you in just a moment, is able to prevent dependency injection attacks by not allowing a string to be inserted into the parameter. So I call my suspend get connection, and then I run another suspend in order to do the work that of using that connection and then running the query. So as you can see, it looks like sequential code even though it's not. So then in here I need to run what's called a prepared query, and all that means is that it's a query that will take parameters. So in our case it's a tuple. So then once we get the query back, again we have to check, was it successful or did it fail? Similar to what's going on up here. And then we can handle whatever it is that we need to handle if it's successful, or we can fail out if it's not successful. So what I want to do is, instead of repeating this code, because I intend to use it multiple times, actually let me just write it here and then I will reuse it. So this suspend coroutine has this parameter that allows when the action completes to be passed in and a notification to happen. So for testing purposes, let's write out what we got back. If it fails, then we will exception, just like in the connection code. So this is basically all we have to do. Now I'm going to take the whole thing and I'm going to wrap it in a try catch. Now what I want to make sure I do is I want to make sure that I always close the connection, since we're running off of a pool, and if I leave them open then another call cannot make use of that connection. So whoops. Okay, so now I'm going to take this code and I'm going to put it into its own function, and this function does not have to be a suspend because we're not doing anything asynchronous in here. Just to be clear, whenever a query returns, it's going to have basically a generic object in there, and it's going to be this stuff, right? Because it has to be able to handle, you know, all the different types of tables that you have with different data types and all that stuff. So that's why this is there. So let's just go over this real quick. So then we have our continuation is basically a parent somewhere above this code somewhere in the hierarchy. And then we have the connection from the connection pool that whether there's an exception or not, we have to close, make sure to close. So that's why we have it in the finally. And then we have our actual query object that if it's succeeded, then we can get the results from it. And again, the results are always of this type. So later on, when all these calls are completed and our other suspend function will get back this result set, then we'll be able to convert it to whatever entity object that we want to. So I just add this call in here, pass in the parameters. Let's just fix this indentation. So then now we have our helpers. Just make sure there's no obvious errors in here. Okay, so now that we have our helpers, we can go back to our get user and then we can make the appropriate call. So again, this has to be suspend because we're going to be running inside of a coroutine, and a suspend call can only run either inside another suspend function or inside of a coroutine. So we call our prepared query. So we call our prepared query. We're first going to pass the pool. Then we're going to pass our actual query. So that's just going to be super simple. So this is parameter number 1. It just means that if there's more than one, then you have parameter number 2, number 3, and so on. So then we want to pass our tuple. In this case, again, we only have one parameter, so we just pass this ID. So now we have a call that totally executes appearance-wise as a synchronous function, even though it's actually asynchronous internally, making two asynchronous calls, the one to get the connection and the one to use the connection to make a query. But as far as we're concerned here, it just looks and feels like a regular synchronous function. So once we get the rows, again, it's row set row, and even if you have only one item, it will always return as row set. We're going to create a set of private calls to do the translation for us. So this guy is going to convert from our data type of row into our entity type. So just to be clear, by using with, we're able to use the row object. It becomes the this object, and we don't have to do this. I mean, this entity has only a handful of properties, but as you can imagine, if you had a lot more complex entities, it can be a pain to write all those out. So this is definitely a handy feature. So we put it in here, and again, because they always come back as multiple, we're going to do this. Now, so we have our get user. It's been made into a suspend function, calling another suspend function, which internally calls two suspend functions, and then converting that data into an actual entity type. So now we have to follow the code path, and we have to convert our user data fetcher. So we're going to make this into a completable future. And the reason why we're going to do that is so that we can get back into standard Java promises, futures, callback land, since ultimately vertx is written in Java. So in order to do that, we need to be able to return a completable future instead of the entities directly. So that's what I'm doing here. Now here's the problem. I'm trying to merge back into Java callback land from suspend and coroutine land in Kotlin. So the way that I need to do that is, because this function is not a suspend function, I need to have a container that either is a suspend function or another coroutine. So I'm going to create a coroutine container for my suspend code. And then when this call completes, missing imports. So when this call completes, it will be captured by the completable future, and then at the appropriate time, the completable future is going to notify. So again, I'm returning a completable future. It is accepted by the data fetcher. It internally is returning a user entity, a single user entity. And then inside of this non-suspend function, if I want to run my suspend functions, I need to have either another suspend function or a coroutine. So I'm going to create my initial completable future, wrap my suspend function inside of a coroutine. It'll run whenever it runs. It'll finish whenever it finishes. But because my future completion event is accepting the result of my getUser call, whatever is accepting this object returned object will wait until this completes and then get the appropriate data. So then now I have to update these calls so that they use the newly created object that we just made. Whoops. Let's see. Okay, so then what's the problem here? All right, so since we're not ready to create or update these calls, let's just put in empty data for here. All right. All right, so it looks like it went through. So I've not made any changes to this client-side React app, but I am running it currently. So let's see if this brings back a user. And it does. And obviously we haven't done anything with the tasks yet. So, and just to show you, actually just to show myself, let's see what's in here. So we got John in there. Okay. So next, so let's do get tasks now. So once again, any suspend function must be inside of another suspend function. And because these are suspend functions, we're going to be able to return the entities directly. So actually, let's create a new suspend function for queries that have no parameters. So it'll basically be this. We're getting the connection, we're running our subroutine, we just run a query, and there are no parameters. And that's it. So then we could take our, let's import that. It'll have very similar parameters. So in this case, all we're trying to do is get the list of tasks back without any filtering of any kind. So then we're going to need an object that can convert again. So we'll create two functions. We'll create one that will get an individual, get and convert an individual task. So again, we're going to use with. So this takes care of the single. So, whoops. So then this will do everything else. We need to import that. So we're going to create a list to populate. We'll loop through them. Take each row. And then we'll return the tasks. So then that's what we have. So again, a suspend function calls into another suspend function. So then in our entity fetchers, we have to update the signature. The reason why I'm using IO is because these calls are IO based calls to the network. So that's why I'm doing that. And when the future completes, it's going to get back a bunch of tasks. That's right, it's an array list. Let's not deal with nulls. Alright, so that looks like it compiled. So let's see what we have in here. So we have a bunch of tasks. These are just test tasks that I added earlier while I was testing. So again, we're making true DB calls. We're using Kotlin suspend and coroutine to be idiomatic in our Kotlin code. And that's it. So now we're going to do a mutation, which is this guy right here. Now the thing that I want to do here is I want to do an insert, and then I want to receive the results back from the database. So in this case, we are doing another prepared query because we're going to pass parameters. So we're going to insert into the tasks table. We're going to insert the title, and we're going to insert the description. It's going to be parameter 1, parameter 2, and we're going to receive back the ID. Again, no matter how many come back, in this case we just want 1. So we're going to get back that ID. Add a space there. We're going to get back that ID. And then let's make a secondary call to get back the object. let's call it new task. I'm going to pass in this ID that we just got back before. And then we're going to return the first element. We should probably call this row. Okay, so we're going to get rid of all of this. I'm going to return the future. I'm going to create a new coroutine. We need to grab our parameters. We don't need that. This might be null. Could actually do it this way. I'll just show both. So we complete. And then once we complete, we run our task with our two new parameters. Okay, so that compiled successfully. Let's take a look. So what do we not have here? Task A, B. So I'll put task C. And there it is. So again, these are all Apollo GraphQL mutations. Not sure what happened to the formatting there. So if I were to run and I got back title, see all the titles including this last one that we just created. If I wanted to do the mutation, add task D. description. So I want to get back, let's say I want to get back everything. As you can see there. All right, so now that we're basically done, let's take it that last step further and make it idiomatic to Kotlin basically all the way. So if you look at the code that we have, we are manually returning completable futures by creating them. So what we can do instead is basically use a utility inside of the coroutines namespace that will automate a lot of that work. So Kotlin X, coroutines, future. So this is going to automatically create the future object for us and return it on our behalf. Let's see, I just want to make sure I didn't leave a scoping out. Just make sure it compiles. So what's going on here is we can use the shortcut syntax and have the coroutine return directly. As you can see, it returns a completable future. So if we go back to the site, so that was get user, so this should load. So it still loads, but you can see it's a little bit cleaner. The tie-in between coroutine world and completable future callback world is a lot more integrated, and it reduces the need for us to do a lot of extra boilerplate. So I'm going to do the same thing across the board. So again, we make this a future. We get rid of the future wrapper. So this is to get all the tasks. So it still runs, but it's a lot cleaner. Do the same thing over here. Remove the future wrapper that will automatically be created for us. Again, a lot more streamlined code and a lot more idiomatic to Kotlin. Make sure it compiles. So I'll just refresh it one time. So task E is the last one with a proper name. So I'll do task F. And that's it. So true entity access to the database, both read and write, being brought back and sent in via GraphQL, but at the same time making use of Kotlin idiomatic syntax with coroutines. But also integrating into the Java world of promises and futures. That's it. Thanks.